Across India, roughly 140 million households depend on agriculture for their livelihood. But the traditional system supporting them is buckling under the weight of a severe and worsening shortage of physical labor. Without enough hands in the dirt, crop protection falls to workers carrying heavy tanks across uneven terrain, surrounded by a mist of chemicals. It is grueling work that results in inconsistent coverage, immense chemical waste through overspray, and serious health risks. Because this process relies on human endurance rather than precise measurement, farmers are left managing a single season's yield on hope. They pour resources into the soil, but without data-driven protection, crop yields stagnate and the physical land degrades. Protecting the foundation of the Indian economy requires removing these physical limitations from the equation entirely. Ojas Aerospace approaches this problem with a strict sequence. Before a single drone takes flight, you must first digitize the physical farm. They achieve this through the virtual farm network. This graphic illustrates their digital twin architecture. The smallest unit, the pixel, represents exactly 1 square millimeter of farmland. At this resolution, the AI scans individual leaves to detect microscopic threats, like red rot or borers, long before human eyes spot the damage. Gathering this ultra-local intelligence bridges the gap between the physical soil and a networked database. It turns raw, unmeasured dirt into a precise mathematical asset. You cannot solve a 100 million acre crisis with blanket policies. You solve it by gaining absolute control over the smallest possible variable. That microscopic logic scales up. 10,000 pixels form a 1 centimeter cube, and 10,000 cubes create a 1 square meter tile. This foundational unit receives a unique GPS tag, recorded onto a blockchain, creating a secure, tamper-proof record of the land's health and treatment history. Once mapped, the data requires a physical enforcer. The Vaigo drone, built to defense-grade specifications, lifts a massive 70-liter liquid payload into the air. The drone relies on RTK positioning, an advanced navigation technology, to fly the digital tile grid with centimeter-level accuracy. It applies chemicals only exactly where the data dictates, cutting out the drift and overspray of manual labor. This drone functions as a high-capacity precision printer. It reads coordinates from the blockchain and executes agricultural commands directly on the physical soil. Operating complex, heavy-lift aerospace technology in isolated, dirt-heavy environments presents a massive logistical hurdle. These machines require strict maintenance, power, and data links to survive. To solve this, Ojas Aerospace deploys the MegDev drone station. Built from repurposed shipping containers and powered by extensive solar arrays, each station functions as a self-contained 1-acre digital airport placed directly in the rural landscape. The station's internal workflow is highly automated. At the 6-bay charging docks, rapid battery swapping modules cycle power immediately to keep flight operations continuous. The entire process is managed by the internal Hal ERP system. Local farmers simply approach the station's multilingual digital kiosk, confirm their field coordinates, and initiate complex autonomous flight operations with a few taps on the screen. Ojas Aerospace is installing permanent, self-sustaining aerospace infrastructure directly into these local communities. That single village station is one local node within a highly structured national operational nervous system. This animated graphic maps the 4-tier hierarchy. Data and logistics flow upward from localized Hal village centers to Vaigo block centers, up to MegDev Estrict stations, peaking at FAME hubs. This model is executing a phased rollout across all 831 Indian districts. Using this rigid, tiered architecture guarantees that the operations scale consistently. It takes an isolated agricultural tool and multiplies it into a decentralized nationwide data grid. This physical expansion is driving a human transition. Local youth and women, operating under the Hal Didi program, are leaving traditional manual labor to manage these hubs as certified technology leaders and rural entrepreneurs. Establishing this aerospace footprint at the district level unlocks the network for broader applications. Once the hubs are active, they facilitate emergency medical logistics, industrial pipeline inspections, and search and rescue operations in off-grid regions. Farmers are transitioning from manual laborers exposed to chemicals into remote managers overseeing predictable, data-driven yields. By linking the smallest pixel of soil to a synchronized national grid, Ojas Aerospace has engineered India's sky economy, securing the future from the ground up.